Okay, this video is for the 2018 mock exam. This is going to be the non-calculator multiple choice. Number one is a straightforward derivative. We do have to remember that it's a good idea to think of that 2 to be sitting way out here, and that helps us remember to do our chain rule. So we would have 2 cosine of 3x minus 5. And then all raised to the first, and then times the derivative of the inside, which the derivative of cosine is going to be negative sine. So then we would have negative sine of 3x minus 5 times the derivative of our angle, which is 3. So the first thing we can do is go back over here and eliminate some answer choices, which A and B very quickly are gone. And then we notice that D should be the correct answer because then we can multiply our 2 and our 3. Okay, moving on to the next problem. This is a straightforward integration problem. We do need to do some rewriting. So I'm going to rewrite this as t times t to the 1/2, and that's all raised to the negative 1. And then I'm going to combine these on the inside, so that's going to be t to the 3/2 raised to the negative 1. And then that's going to give us the integral of t to the negative 3/2 dt. Now let's go ahead and integrate. So that's going to be t to the negative 3/2 plus 1 all over negative 3/2 plus 1. And so let's see, that's going to give us, here we're going to have t raised to the negative 1/2, and then that's going to be over negative 1/2, so we're going to flip that up and make that negative 2. So we have negative 2 times t to the negative 1/2 plus c. So our correct answer should have been A. For number 3, we will go ahead and do our quotient rule. And so for our quotient rule, we have the bottom times the derivative of the top minus the top times derivative of the bottom, and it's all over the bottom squared. Now I would stop here and look at my answer choices, and the bottom squared, they have that included for all of these. Now as far as really working out every part, notice all of these coefficients are different. So really all we have to concern ourselves with is getting the correct coefficient for x cubed. So here, from the first term, I would have negative x cubed, and I have minus, and if I multiply out here, I have negative 3x cubed. And so let's see, we have plus a positive then, and so we're going to have positive 2x cubed, so the answer choice must be C. Okay, number 4, we have the position of a vector, and then we are asked where y is a twice differentiable function of t. At time t equals 1/2, what is the acceleration of the particle? So from let's see, from position to acceleration, I needed to do the derivative twice. So I'm going to start with the first part. So let's see, if we do the derivative of 4t cubed, that's going to give us 12t squared. And then that's going to give me 24t. And so 24t at 1/2, that's going to give me 12. So that gets rid of choices A and B pretty quickly. All right, now for the second one, this is going to have to be a chain rule. So the first derivative here is going to be y prime of 2t times the derivative of 2t. And so if I do the next derivative, then I'm going to end up with 4y double prime of 2t. And so very quickly, we don't have to worry about plugging in because notice the coefficient there is 4, and D is the only answer choice there for that. For number 5, to what number does the series converge? And the only convergent value here that we can do is going to be an infinite geometric. So here, the sum of an infinite geometric is your first term over 1 minus your ratio. So we need to see what is the first term for this. So when k is 1, let's see what we get here. And this is going to determine our a, which is our first term. So I'm going to have negative e over pi raised to the 0, which is going to be just 1. So I know here in my formula I have 1 over. And now let's see, what is our ratio? What are we multiplying by each time? Well, what we're multiplying by each time is right here inside the parentheses. So we're going to have 1 minus negative e over pi. And so we're going to have 1 over 1 plus e over pi, common denominators being pi. So 1 over pi plus e all over pi. And let's see, so when we flip that over, that looks like it's going to be answer choice C. For our next problem, we have to see which of the following has to be true or is true. So here again, we're looking for is true, not false, and that sometimes can be tricky. So let's see. For A is the definition of a derivative, but we don't know really a value for A. And notice that we're not continuous everywhere, so we don't know that that derivative exists everywhere. So here can't be A. B, the limit from the left of A equals the limit from the right of A. That one is not equal, sorry. So then here that's false because they are equal. Now here we go. It's going to have to be C, and this is the third step in continuous. And so we see that our function is not continuous at x equals A. So here we see that C must be the correct answer. All right, for number 7, we are asked to find the value over here from negative 10 to 6 of g of x, and we're given pieces of it. Now the first thing we need to do with the first part that we're given, we have to flip our endpoints, so we will need to put a negative out front. And so here that's going to give me all of that's equal to negative 3, but this negative and this negative will cancel each other out. And so for the rest of this, then I have from negative 10 to 4, and then this one's from 4 to 6. So all that's left for me to do is just add these two values together. And so when I add those, I do get 8. So the right answer choice there was D. Okay, moving on to the next problem. This would be a formula. And let's see if we can remember the formula. We will be integrating from one angle to the next, and it's the square root of 1 plus the derivative of the function squared. So there's our formula. And so for here, the biggest thing that we have to remember is when we do the derivative here, the derivative of sine is cosine of that angle, but it's also times the derivative of that angle. And then if we square f prime at x, then that's going to give me 9 cosine squared of 3x. And so that answer choice should be D. All right, for this problem, we need to find the derivative and then plug in our x value. So for y prime, here we do need to do the product rule. So we have first times the derivative of the second plus the second times the derivative of the first. Now we need to plug in our x value. So y prime equals the natural log of 2 times e to the natural log of 2 plus e to the natural log of 2. Now this is an old property. Here, natural log of 2, not much we can do with that. So we have natural log 2, but e to the natural log of 2 cancels each other out, and we're just left with 2 plus, and we have 2 over here. So it looks like our correct answer should be B. Our next problem, we have to do Euler's method with 2 steps. But here's the thing, we're starting at f at 3. Sorry for the screen shake. We're starting at f at 3, but we have to go all the way over to 2. So we're going to be going backwards with this one. So this one was a little tricky. Let's set up our chart that we normally do. We have our x value, and then we have our y old, and then we would have our changing x's times our derivative value, dy dx, and then we're going to have our y new, which is the sum of the previous two columns. So let's go ahead and fill this in. We're going to start at 2, which has a y value of 8. My changing x's is 1/2. It's 1/2 times our slope here, which is -6. So that means my new y value is going to be -3 plus 8, which is going to give us 5. Now let's move on to the next one. So now we need our new x value, which we're changing by 1/2, so we're going to be at 2.5. And then let's see, and then here our old y value would be 5. And so our changing x's, which is 1/2 again, times our difference here in our slope, so that's going to be -2.5. And so here when I multiply these, I'm going to have 5 minus 1.25. And so that's going to give me really the y value that I'm looking for, which is 3.75 or 3 3/4, which is going to give us C. For our next problem, we have to do implicit. So our first part, we're going to have 2x, and then we're going to have the product rule. So we have the first times the derivative of the second, and then let's see, plus second times the derivative of the first, minus 3, again, derivative of y, dy dx, equals 0. And now let's go ahead and plug in our point. We are solving for dy dx. So we're going to have 4 plus dy dx, and then 2 dy dx, sorry, plus 1 minus 3 dy dx, and that's all equal to 0. And if we're solving for dy dx, notice we're going to move 1 and 4 over to the other side, so that's going to give us -5 over, and if we combine these two, I have a -1, so that's what I'm dividing by, so my answer choice should be A. Okay, for our next problem, we will have to do partial fractions here. We need to separate this out. And so for the first part, go ahead and factor the denominator. And so when we do, our numerator, of course, is the same. And then our denominator, when we factor that, we should get x minus 3 times x minus 1. And we know whenever we dissolve this into partial fractions, that means we have some numerator over x minus 3 plus some other numerator over x minus 1. And we can go through and multiply all this out. We have 3x plus 1 equals, and this is going to be a times x minus a, and I just real quickly cross multiply here. It will generate the same information that you need. And now let's match up what has to go with the coefficient of 3, or coefficient of x, which is 3, and that's going to have to be ax plus bx, or a plus b. And then what has to go with our positive 1? Well, that's going to have to be -a minus 3b. And we can do some rearranging however you want to go through and solve this. Let's see, I probably solved for a and substituted in. So a is equal to 3 minus b. And so over here I have 1 equals -3 plus b minus 3b. And it looks like, let's see, we're going to get 4 equals 2b, so b is going to be -2, which then means that a over here is going to have to be 5. So now we're ready to rewrite our fractions and do some integration. So we're going to be integrating 5 over x minus 3 plus -2 over x minus 1. And so we're going to have 5 times the natural log, absolute value of x minus 3, and then minus 2 times the natural log, absolute value of x minus 1, and of course plus c. And let's see, what answer choice is that going to be? That should be answer choice D. For our next problem, matching our slope field to the differential equation that we're given, notice x squared plus y squared, so that means that is always positive. So if we see any negative slopes, we can automatically cross out those answer choices. And so that leaves us with trying to decide between B and D. But if we look very carefully here, especially on D, notice that we have some slopes that look like they are tending towards 0. And so here we can't get a 0 since both terms would be positive. There's no subtracting. So that leaves answer choice B. Right, the next problem is dealing with the definition of a derivative. And so let's see here. When we're going through this, remember the initial definition, we had the limit as h approaches 0, f at x plus h minus f of x all over h. And so with this problem, notice that we do always try to pick out the given function that's behind the minus sign, and notice all of those actually line up, so that's not going to help, and all these denominators are over h, so that's not going to help. So let's go back over to here. Notice that we've replaced x with x plus h, so wherever we see an x value, so up here in the original where we have x squared, I don't need to see x squared. I need to see x plus h all squared. So that eliminates a and b. And then the next part, I need to make sure that I have plus 2 times x plus h. And so I do have that through here. So let's see what the right answer choice would have to be. So here, these look identical, but right here, that was the kicker. We always had to make sure h was approaching 0 because h was the defined distance between our 2 points. So our answer choice should have been C. Right, over on the next, we're looking for which of the following statements is false. So let's see, what could we do? Let's see, the first one, 15a. The limit as x approaches 1 of our function, and they're saying that equals 0. Right here is the graph of f of x, so that one's actually true. And let's see, the limit as x approaches 2 does not exist for g. That's also true. Now let's look at these transformations here. So that with this first notation, that's telling us that we need to move my graph of g, that needs to move back to the left 1. And so let's see what that is going to do for us, because very quickly we would want to look at this and say, well, this piece is now moved back here, this piece up here is moved forward 1, but we don't know, again, over here, remember we have to consider both parts of this limit. So for the first part, let's say the limit as x approaches 1 from the left of f at x times g at x plus 1. Well, if we look at here from the left part, we see that the f of x part is going to be 0 times, and then from the left side of our g of x is going to be 1. So the value is 0. And very similar, if we look on the other side of 1, if we approach this from the right side, well, again, notice what happens. Our limit as x approaches 1 from the left of f of x. Well, that one is 0 times, and then from the right, we do have -1, but that will, again, turn back around to 0. So the limit from the left and from the right, they do equal each other. Therefore, that limit does exist. Therefore, my answer choice is C. All right, for number 16, which of the following is the interval of convergence for the series? So here, when we go through, we always set up our limit as n approaches infinity, and the absolute value of the n plus first term, so x plus 2 raised to the n plus 1 over 2 to the n plus 1 times the reciprocal. So that's going to be 2 to the n over x plus 2 raised to the n, and that absolute value is less than 1. So here, and we can assume that because of this ratio test, we're told that here we do converge, and so that means the statement must be true. And so let's do some reducing. We have the limit as n approaches infinity. Absolute value, those n's are going to cancel, and this 2n and that n. So it looks like we're left with x plus 2 in the numerator over 2 in the denominator, and that has to be less than 1. And when we do our limit, we're just left with the absolute value of x plus 2 over 2. And I'm going to go ahead and multiply that 2 over to the other side. And so this problem is like the never-ending problem, I do believe. And so I have -2 is less than x plus 2 is less than positive 2. So we have -4 is less than x is less than 0. Now, looking at our answer choices, because we do have to test our endpoints for convergence or divergence, and notice that when we start eliminating some answer choices here, C and D, and notice neither one of these answer choices included 0, so don't waste your time with 0. So let's waste our time with -4. So to see whether or not we include that endpoint, we need to check to see if we converge or diverge. So we're going to plug in our -4. So that's going to give me -2 to the nth. I'm plugging in for x over 2 to the nth. And then that's going to really give me -1 to the nth, isn't it? So let's think about this series. N equals 0 to infinity of -1 to the nth. So this is just bouncing back and forth between -1 and 1. So here this one does not converge. It's just kind of going crazy. And so here we're going to say that the answer choice must then be A. When I first saw number 17, I thought, oh dear goodness, but let's think about dividing up all of the stuff underneath the integral, or underneath the square root, sorry. So we have the integral from 0 to 5, and really if we divide this up, that's really just 1 minus 1/5 x, isn't it? Because we can separate this out. And then it's like, oh, wait a minute. We could just do a u substitution here. And so we could say u equals 1 minus 1/5 x. So du is actually just -1/5 dx. And so we can adjust our endpoints also here, or we can leave it and come back. It's really not going to matter. So let's see if we integrate here, and I'll go ahead and adjust my endpoints. So if I plug in 5, then that's going to be 1 minus 1/5 of 5, so that's going to give me 0. And so let's plug in 0, and we get 1 minus 0, which is 1. So we're going to have to flip those endpoints, my gracious. And then we're really integrating just u to the 1/2. So let's see, if we do that, we don't have to worry about going back to what x was. Then we have negative, and that's going to be u to the 3/2. So in front we have 2/3. And this is going to be evaluated from 0 to 1. So notice that when we go plug in, it looks like we just have negative 2/3. So that kind of made this problem a lot easier than what we originally thought it would be. So our answer choice here, don't forget to go back. So we had negative, let's see, 2/3. But we also had over here, we had our, and I forgot to bring it in, but right here. So I need to multiply by a -5 to balance that, don't I? So let's go back and do that. I'm terrible about forgetting that. So my answer, 10/3, and let's see what answer choice that is. Answer choice B. Okay, so which of the following limits are equal to -1? And so if we look at answer choice 1, and we look at the limit as x approaches 0 from the left of the absolute value of x over x, think about a t-chart, and we are going to be filling this in from the left side. So let's choose -1, and if we plug in, we get -1. If we plug in -0.9, we still get -1, and we could continue this, but we see that this one here, that's definitely going to give us a limit of -1. So, well, that tosses out our number C, letter C. All right, so let's look at, let's see, the second one. Let's see, if I plug in 3, I'm going to get a 0 in the bottom. So let's factor the top, or you could use L'Hopital's rule here, couldn't you? So y'all probably would rather do that. So we have 2x minus 7 over -1. And if we plug in 6, we're going to get, or plug in 3, we're going to get 6 minus 7, which is -1 over -1. So, can't be 2. So let's see, did that get rid of, oh, so we've got to test 3. And this is going to be a Betsy. Our x is approaching infinity. So we look at this ratio, which is -1. So it's going to be 1 and 3. Okay, for our next problem, let f be the function given by blah. What is the approximation for 1.5? Found by using the line tangent to the graph at x equals pi over 2. This is where if we don't remember our trig values, it's really going to suck, but hopefully we all remember them. So we have f at pi over 2. First thing we have to do is find our y value. So that's going to be 2 cosine pi over 2 plus 1, and cosine of pi over 2 is 0. So that generates 1. So I know I have the ordered pair pi over 2, comma 1. And now I need f prime at pi over 2. So first let's look at f prime at x. So let's see, that's going to be -2 sine x. And then f prime at pi over 2, well, that's 2 sine of pi over 2. Sine of pi over 2 is 1, so that's going to give me -2. So let's go ahead and write the equation of our line. We have everything that we need. So we have y minus 1 equals -2 times x minus pi over 2. Now let's go ahead and move our 1 over, and we can go ahead and approximate also. So we're going to have -2 times 1.5, which is, it looks like we need to use 3/2, minus pi over 2 plus 1. And it looks like they multiplied this one out. So let's see, that's going to give me -3 plus pi and then plus 1. So looks like we're going to have answer choice C. Okay, a particle moves in the xy plane so that the position 4 times bigger than or equal to 0 is given by, we have parametrics. X equals blah and y equals blah, where k is a positive constant. What is the value of k? Well, that's great, but let's see. They tell us that the line tangent to the particle's path at the point where t equals 3 has a slope of 8. So that's kind of useful here. So let's make note of that. So let's go ahead and see, well, what's the slope going to be? So first thing we need to do, let's find dy dt. So dy dt, that's going to be 2kt. And then let's find dx dt. That's going to be stuff prime over stuff. So stuff prime should be 1, and the stuff is t plus 1. That's the stuff. And so now we look at this fraction. So 2 times kt over 1 over t plus 1. And let's see, we were told that all of that, when t is 3, is equal to 8. So let's go ahead and plug in 3 also. Forgot to do that. So if we do, we're going to have 6 k times, let's see, what was that? We're going to plug in 3. Yeah, 3. So we're going to have 4. And all of that's equal to 8, so k is 8 over 24, which most days is 1/3. All right, so for the next problem, we was the average level over the 10-week with a trapezoidal approximation. All right, and that gives us our 3 intervals, which is pretty nice. Now, since it wanted the average, remember we have to do 1 over 10 minus 0, and then that's going to be times, and we have 1/2 the height, which is the difference of our x's or our t values, times the sum of our bases, which is going to be our y values, plus, and you continue this through, so we're going to have 1/2 times 4 times, and if we add those, we're going to get 390, plus, and I'm slide over my screen for a second, hang on, plus 1/2 times 4 times 370. And when you work out all of that awesomeness, then you end up with answer choice B. Hey, this problem's a little bit of sunshine minus voodoo. So let's see, we have to go through and pick our U and our V. My U value I chose to be 1/2 x. That way my du value is really nice to work with. It's just 1/2 dx, so that's kind of nice to work with. And then I made my dv value would then have to be e to the negative 3/4. Oh, my pen's gone crazy. Hang on, folks. Negative 3/4. There we go. That's a little bit better. X dx. And so when I integrate that to get my v value, I do have negative 4/3 and then e to the negative 3/4 x. All right, so my sunshine, so I have u times v, so I have 1/2 times negative 4/3 e to the negative 3/4 x. So there's my sunshine. And I would stop there and look at my answer choices because I am super duper lazy here. And I would see, do I really even need to continue? Well, if I multiply those, I'm going to get negative, what's that going to be? 2/3 e to the negative 3/4x. And check your first terms, and there's only one term that contains that, hot dog. So that's going to be answer choice B. Now you're welcome to finish out the problem, but I wouldn't in this time setting. Number 20, what number is this? 23, they give us an expansion, and they want to know, well, what's the derivative of that expansion? And you have a couple of options here. One option is you can write out the terms of this expansion, the first couple of terms, and then do the derivative of it. Or you can just do the derivative of your general term. So let's do the derivative of the general term first. Now remember, we're taking the derivative of x to the 2n over n factorial. That's our general term here. Now n factorial, that's just a number there. So let's think about this. Whenever I go through the derivative, multiply that down to the front. So I have 2n times x to the 2n minus 1. And that's over n factorial because, again, that's just the denominator, just a number. It's not a variable. And if we go over and look at our answer choices, notice that's going to give me answer choice D. Now, if we did not see how to do that derivative of the nth term, which can be confusing, let's write out a couple of terms here. So when n is 1, if I take this and I just expand this summation. So I get x squared, and then I get plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial. And let's do one more. So that's going to be x to the 8th over 4 factorial. Now let's do the derivative. All of that is an approximation of f at x. Oh no, I put one too many dots. Whew, okay, got that fixed. So if I start doing the derivative through here, notice I get 2x plus, and notice again, looking at these first terms, that's the only one that had 2x in it. So that's answer choice D. But whichever way you choose to do it is fine. It is your choice. All right, so now let's look at 24. And again, this one says average value. So with average value, remember we have to do 1 over b minus a. So we're going to have 1 over 4 minus negative 2. And it says, let's see, the average value of this continuous function f over this interval is 12. So over the interval from negative 2 to 4 of f of x dx, that is 12. Well, let's see, that's really going to be 1/6 times all of this. So I'm going to move that 1/6 over to the other side. So I have negative 2 to 4 of f of x dx. And that's going to be equal to 6 times 12 is 72. All right, and so I was doubting myself there for a moment. Now over here, this is the function divided by 8, and we can move that constant on the outside. So it's really asking us, well, what is 1/8 of the integral from negative 2 to 4 of f of x dx? Well, what is 1/8 of that? Well, it's 1/8 times 72, which most days generates a 9. What is the radius of convergence for the Maclaurin series of that? Well, I don't know what that is, but I do know that Maclaurin series means that we are centered about 0, so that's kind of useful. Now, I don't know right off the top of my head what that expansion even is as far as the terms of it, more or less to find the radius of convergence. But what I do know is 1 over 1 plus x. I do know that power series, and we had 1 plus x squared plus x cubed, and so forth. Now, it looks like down here that they've changed x to x squared. They've plugged in an x squared for x. So 1 over 1 plus x squared, well, that's going to be 1 plus x squared plus x to the 4th plus x to the 6th. So I think we're getting somewhere with that. And then we multiply by 2x. So I really need the general term for this. And for up here, I know that general term we started at n equals 0 to infinity. And it looked like it was just going to be x raised to the nth power. So the general term down here, kind of by the same idea, from 0 to infinity, that's really going to be x, but it looks like it's to the 2n. So, okay, getting somewhere here. And so to get that 2x, I really just need to multiply everything here. And let me slide my screen over. All right, so to get that 2x effect here, that looks like I need to multiply both sides by a 2x. So, okay, I'm seeing what's going on here. And so really then that tells me that 2x over 1 plus x squared equals, we got all that yada yada yada, or we could just look at our summation here and say, well, it's the same thing as n equals 0 to infinity of, and then we've got 2x times x to the 2n. So there's us a good general term. Now we want to know the radius of convergence. So we're assuming that this does converge, and to find that radius, now we've got to go over and set up our limit. So we have the limit as n approaches infinity of, and looking at our general term, we do our n plus 1 term. So if I do that, then I'm going to have 2 and then x squared, isn't it? Well, let's go back and look. Did we we could condense this down, couldn't we? Let's do that. That might make this a little bit easier. So this right here, I could rewrite that to be 2x to the 2n plus 1. And that looks a little bit better, because if we start doing our n plus 1 term, then we're going to have 2x, and then let's see, 2x squared, or 2x to the 2n plus 1, which is really going to be, let's see, 2, and we need, good Lord, my pen ain't writing, 2 times, let's see, and I need the n plus 1 term, so we're going to make that n plus 1 plus 1, ooh, that looks terrible, over, hey, it's only one term, well, that's nice, 2 to the x to the 2n plus 1. So that looks okay. And so that's got to be less than 1. Well, what in the world is this going to be? So we have the limit. As y'all can tell, I'm just making it up as I go. Let's see, those 2's are going to cancel. That's going to be x to the 2n plus, 2n plus 4, no, 2, 3, isn't it? 2 all over. I don't do much adding here. And so, let's see, that's got to be less than 1. So, goodness, what is that going to end up being? Oh my goodness. So let's see, we have like bases, we're dividing. Oh, let's throw back to Algebra 1 days. So we've got to subtract our exponents, or that's what I'm going to make up as I go. Well, 2n plus 3. So let's think about this. I'm saying 2n plus 3 minus 2n minus 1. So that's going to leave me a 2, isn't it? Well, look at there. That is so handy. So then that means x squared, absolute value x squared, that's kind of redundant. So we're just going to say x squared, let's see, x squared is going to have to be, what, less than 1. All right, so let's see, let's see, x squared less than 1, that, and what else could that be? Oh, we got to bond it over here too. So really x could be between those two things. So what would be the radius here? Well, the radius of convergence, well, from -1 all the way over to 1 is 2, but a radius, I want half of that, so the radius of convergence is 1. So that's answer choice B. All right, next problem. Looking at this, blah, 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 blah. Mean value theorem. All right. So we have the derivative equal to our slope of our secant is equal to slope of the tangent. Well, for some c value. And notice what they're telling us. We have two different x values, but they have the same y value. So this is good old Rolle's theorem. And that tells me that that old derivative then would have to be for some c value inside there. That derivative 0 because I have the same y value. So I've got like a little parabola going on somewhere. So little baby parabola. We have 0 equals x plus 1 cosine pi x. And do they want, no, they just want to know how many. All right, so let's see, this is really in factored form already. So x plus 1 equals 0, cosine of pi x equals 0. Now they're being a little tricky boogers because here you get x is -1, but -1's not inside that interval. They're being little toots. Also, let's see, pi x, cosine of pi x, and got 0. So let's think about where in the world is cosine 0? Cosine is 0 at pi over 2 and at 3 pi over 2. So pi x would then also have to be 3 pi over 2. And notice right away those pi's cancel out. So we have 1/2 and we have 3/2. So there should be two values that this is going to happen. And so that's going to be answer choice C. All right, so skipping through this problem, we've got all kinds of stuff going on here, but it's asking us what is the greatest rate of change in students per second of the number of students in the cafeteria. So greatest number of, or the greatest rate of change. So that means I need the derivative of the derivative, right? Because this is the derivative, this is the rate of change, but I need the greatest rate of change, so I need the maximum value of the derivative. So let's look at our second derivative of this nonsense, and gosh, I would go ahead though, before we do that, let's rewrite the derivative, because I think that would be easier, because it looks like it ends up being a quadratic. So let's rewrite dp dt is going to be, let's see, cancel off a couple of zeros. So I end up with 1/10 p minus 1 over 2,000 p squared. So yeah, so now the second derivative, that's going to make that a little bit easier. So the second derivative is going to be 1/10 minus, well, that's going to be 1 over 1,000 most days, p. And so let's set that equal to 0. So I have 1/10 minus 1 over 1,000 p. And so let's see, I'm going to add that, so I get 1 over 1,000 p equals 1/10. My gracious, what a mess. And so let's see, and multiply by 1,000. And so it looks like p is going to give me 100. Yeah, our second derivative, assuming I did my numbers right. But now that's going to tell me where the maximum value is, not what the maximum value is. To find what the maximum value is, I need to go back and plug in to my derivative. So let's see, if I plug in, let's find dp dt at p equals 100. So that's going to be 1/10 of 100 minus 1 over 2,000 times 100 squared. Oh dear goodness, that is absolutely disgusting. All right, so let's see, what in the world is that going to give us? So here is 10, and let's see, the other is going to be 100 squared, not that. Oh my goodness. All right, so I have 10 minus 100 squared, so 100 times 100, all over 2,000. So that looks like that's going to give me 5. Well, that worked out very nicely. So 10 minus 5 is 5. So answer choice A. Our next problem is an awesome related rates problem. So let's see, we have our volume given to us. Our volume is x cubed. And let's see, we are also told, let's see, the volume is increasing at a constant rate of 40 cubic centimeters. So I know dV dt is 40, and I should put units there, but I tend not to. And let's see, at the instant when x is 2, what is the rate of change in x with respect to time? Oh, well, this one's a pretty straightforward one. Okay, so we've got dV dt equals 3x squared dx dt. And let's plug in. So I have 40 equals 3 times 2 squared dx dt. So it looks like we're going to have 40 over 4 times 3. So it looks like we're going to have 10/3, or answer choice A. All right, this problem is very similar to the Maclaurin radius of convergence problem, where it's like, okay, they give us this terrible looking expansion, or the problem, and they want the expansion of this. I'm like, I don't know what it is. So what I did whenever I worked out this problem was I looked at it as 2 separate parts. I said, all right, so let's just look at the numerator. So I have e to the x, and then I have plus 1 over e to the x, or I can leave it e to the x, dear goodness, e to the x plus e to the negative x. Either one of those. And then come back after it's divided up and then divide it all by 2 and see what we get. So let's look at the expansion for e to the x, and then we can transform it. So the expansion for e to the x, we saw e loves everybody. It's going to be every part. Nothing's left out. So I have x squared over 2 factorial plus x cubed over 3 factorial, x to the 4th over 4 factorial, and so on. Well, what would e to the negative x look like? Well, e to the negative x would be 1 minus x. Well, x squared, that would still be positive over 2 factorial, but this one would be negative x cubed over 3 factorial. And again, back positive, so that's going to be x to the 4th over 4 factorial, and so on. Now, we're adding these. It wanted us to add these, so I just drew a line and added them. What the heck? So I have 2, and then coolest thing ever, that cancels. Plus 2 times, because there's 2 of them, x squared over 2 factorial. Oh, cool thing. So it looks like all of the odd ones are canceling out. I'm like, well, that's pretty doggone sweet. So this is going to be our e to the x plus e to the negative x. And then if I come back and I've got to divide every part by 2, well, look at there. Everything just falls away. All of those outside 2's. So then that leaves me with answer choice A. So this problem ended up not being as terrible as it looks. All right, number 30. Which of the following statements about the series is true? And they kind of got a little jiggy with it here. So let's see. Converges or diverges by the nth term test. So let's address that. In other words, by the nth term test, and we discussed this briefly, very briefly, it's saying, hey, if n approaches infinity of my sequence, that has to equal 0, then we know it converges. We don't know what it converges to, but we know something's going on. Now, if it doesn't equal 0, then it diverges, and then we're done. So, but looking at this, here 1 is stationary and 2 to the n is growing super duper big as n approaches infinity. So here we know that this series is not going to diverge. So we can go ahead and remove those 2 because we've used it. Now we don't know for sure that it's going to converge by the nth term. Really, this nth term test is just for a divergence. You know automatically, it's really a test for divergence, that this series is going to diverge if it doesn't equal 0. But this one, it does equal 0, so we are like, okay. So look at the 2 things we're left with to compare it to. Well, which one does this look like it can be compared to? And you're right, it can be compared to D. Here 1 over 2n, because it's geometric, I'm multiplying by a half each time. So here by our limit comparison, we see that the answer choice has to be D.